So hello again everyone. Today we're going to take a look at the May 2019 past paper, and we begin with a simple fractions question. So let us first evaluate the numerator and then we will follow up with the denominator. So doing it in stages. For the numerator, let us first convert to improper fractions. So that's 4 2 is 8 plus 1 is 9 over 4 minus 5 1 is 5 plus 3 8 over 5. And if we take a denominator of 20, then we have 5 times 9 is 45 minus 32 over 20. This works out to be 13 over 20. And now we include the denominator. So we have 13 over 20 divided by 3. That works out to be 13 over 60. For the second part of the question, 2.4 sine 75 degrees. We stick that into our calculator and we get 2.067, so that's 2.07 to 2 decimal places. Let's shift down to number 1b. So in question 1b, we're given a table, and what the table is showing is the fortnightly allocation of wage received by a lady called Irma. So let's write her name down. Her name is Irma. Now Irma, each fortnight, and let's just recall that a fortnight is equal to 2 weeks. So let's just write fortnight is equal to 2 weeks. So in any fortnight, Irma allocates her wage as follows. She allocates X for rent, $629 for food, 2 times X for other expenses, and she saves $1,750, giving a total of $4,320, which is her fortnightly wage. So what is Irma's annual allocation for rent? So if you notice, rent is given as an unknown X, so we can calculate that. So we can write then that X plus 629 plus 2X plus 1750, that should add to 4320, giving 3X then is equal to 4320, and we'll subtract both 629 and 1750. So let's write that here. And that will give us 3x is equal to $1,941. And therefore, x is equal to $647 each fortnight. And this is the amount she allocates for rent every 2 weeks. So in 1 week, so weekly allocation then. So let's just write this is per fortnight. So weekly then is equal to 647 over 2. Which gives $323.50. That is her weekly allocation for rent. Therefore, her annual allocation, so let's write annual allocation, that's yearly, for rent is equal to 323.5 multiplied by 52, and that gives her annual allocation for rent as $16,822. So this is the amount allocated annually for rent. So if we know Irma's annual allocation for rent, then her monthly rental would simply be annual rental over 12. This would give 16,822 divided by 12, and that is equal to $1,401.80. So this would be her monthly rental. But what about her annual pay? Her annual pay, that's right, is simply her weekly pay multiplied by 52. But weekly pay is half her fortnightly pay. So that's right, it's a half of the fortnightly pay, which is 4320, and that gives $2,160. And that's her weekly pay. Therefore, annual pay is equal to 2160 by 52, and that is equal to $112,320. So this is her annual pay. Finally, we're told that Irma has a son whose tuition is $150,000. So let's write son's tuition is $150,000. Now, given that she uses all of her savings to go towards paying tuition, how many years would she need to save to pay for the tuition? So we note that in every fortnight, or we note that every 2 weeks, she saves $1,750. You can see that here. So let's just note that this is her savings. All of this goes towards paying tuition. So every 2 weeks, she saves $1,750. So let's just make that note here. savings is equal to $17.50 every 2 weeks. Therefore, what is her annual savings? Well, we could write that her annual savings would be 52 times weekly savings, where the weekly savings would be $17.50 divided by 2. That is equal to $45,500. So this is the amount she saves annually. Therefore, if she needs to save $150,000, then we need to know how many years will be needed to save this amount. So number of years then is equal to 150,000 over 45,500 is equal to 3.29 years. So we could round this value up to the next whole number, which would then be approximately 4 years she would need to save for her son's tuition. In question 2a, we have 3p squared multiplied by 4p to the power of 5. So multiplying the coefficients, 3 times 4 is equal to 12. Multiplying the indices, we have p squared multiplied by p to the 5. So we add the indices, we're also to 12p to the power of 7. The next part of this question, we need to simplify this algebraic expression. So first, let us invert and multiply. So that works out to be 3x over 4y cubed multiplied by 20y squared is 21x squared. We can now perform some simplification. So 3 will go to 21 7 times, 4 could go into 25 times, and the first simplification gives us 5xy squared all over 7x squared y cubed. So we could simplify further, and we have y squared divided by y cubed, and have x over x squared, so that we end up with 5 over 7xy. Okay, so in 2b, we need to solve this equation for x. So in the first instance, let us find a common denominator, or an LCM if you like. So this would simply be the product of these two. So it's x into 7x minus 1. Now we have 7x minus 1 into this denominator, give us x. So we have 3x plus x into this denominator gives us 7x minus 1 multiplied by 1 becomes equal to 1 to 7x minus 1, and that's equal to 0. Now we can multiply both sides of the equation by the denominator, and therefore we get 3x plus 7x minus 1 is equal to 0. So 10x minus 1 is equal to 0. So this gives 10x is equal to 1. Therefore, x is equal to 1 over 10. In 2c, we have a worded problem, and it reads a number x is multiplied by 2 and the result squared to give a new number y. So what we're told then is that x, when we multiply that by 2 and we square the result, we get a new number y. So we can actually rewrite equation 1 as y is equal to 4x squared. So let's look at part 2 of this question. So we have a new equation, y is equal to x. Let us call this one equation 2. So we now need to solve simultaneously equations 1 and 2 for the two values of x. So we could equate both equations. Y is equal to 4x squared and y is equal to x. Therefore, we could equate the equations by writing x then is equal to 4x squared. So we will solve this equation. So this becomes 4x squared minus x is equal to 0. We take a factor of x and we have 4x minus 1 is equal to 0. So either x, the first factor, is equal to 0, or 4x minus 1 is equal to 0. So when x is equal to 0, we have our first value, and when 4x minus 1 is equal to 0, we have 4x is equal to 1. Therefore, x is equal to 1 over 4. So the two values of x that satisfy both equations are x equals 0 and x is equal to 1 over 4. Okay, so for this question, question number 3a, it's a construction question. We need to construct a triangle ABC such that AB is equal to 8 centimeters, BAC is 30 degrees, and AC is equal to 10 centimeters. As usual, let us make a simple sketch so that we can see where we are going. So first, start the straight line and identify your point AB as 8 centimeters. And next, you will need to construct a 30 degree at A, which would be this angle here. and then you measure along A until you get 10 centimeters. Where you have that, draw the line to complete your triangle. So let's get rid of this and proceed with our construction. Okay, so for our construction, the first point we need to identify is point A. So let's just identify point A here. You can use this as the first point A. And B we know is 8 centimeters away. So let's use a ruler to identify that point. So we have a ruler here. We take a ruler and we identify 8 centimeters away. We can see that this point on a ruler is here. So this is our point. Let's identify it a little more clearly. So this is the point B, 8 centimeters away. Now we need to construct a 30 degree at point A. So to get a 30 degree, we first construct a 60 degree and then we bisect that to get a 30 degree. So let's take our compass. We open our compass to a reasonable separation. We position the compass center at point A and we strike an arc. We then shift our compass and position the point at the intersection of the arc and the line and strike another arc to intersect the first arc. So let's just move the compass in place and we'll strike another arc to intersect the first arc. And this would represent our 60 degree line. Let's draw a line between point A and the intersection. Let's identify the intersection here. We will take our ruler and we will draw a straight line from A passing through the intersection. That would be our 60 degree line. So let's identify that here. So this would be our 60 degree line. So in order to get a 30 degree line, we need to bisect these two. Okay, so what we can do is we can use our compass once more and let's change the color on our compass to indicate what it is that we're doing. So with center at A, let's close our compass a bit. Let's strike an arc to intersect both lines. So let's go ahead, strike an arc, intersect both lines. Then with center at the first intersecting point, we strike another arc. We move our compass to the second point, strike another arc to intersect the first arc. This is bisecting those two lines. The intersection of those two lines is the point we're interested in. We simply draw a straight line from point A through that point, and that would represent our 30 degree. So let's identify that here. So this is our 30 degree. We need to measure the distance from A to C as 10 centimeters. So let's do that now. So we take a ruler and we measure 10 centimeters. And you can see that that point is just about here. That is going to represent our point C. So this is our point C. And finally, we simply connect B and C to complete our triangle. So in 3B, we have a transformation question and we're shown a triangle ABC. And we're asked to draw on this diagram the image of this triangle after it undergoes two successive reflections. So our triangle will undergo the first reflection in the x-axis. So x-axis is the mirror line. So B is 1 unit from the mirror, and therefore B prime is 1 unit on the opposite side of the mirror. So this would be its location here. So let's label it. Let's call it B prime, which means the image after the first reflection of point B. C prime similarly would be at this location, and A prime, let's see how far we are from the mirror. So we could count 1, 2, 3, 4 units from the mirror. So the image A prime will be 4 units on the opposite side, giving 1, 2, 3, 4. So A prime would be here. So we could draw this triangle. So this is our triangle after the first reflection. So next we will need to reflect this image in the y-axis. So let's draw the mirror line on the y-axis. So let's draw again. So now we have the mirror line being the y-axis. So after the reflection in the y-axis, B prime will go to B double prime, which is here. A prime will go to this point, which is here. So A double prime is the image of A prime after a reflection in the y-axis. And C double prime will be the image of C prime after a reflection. So let us count to see where it will be on the opposite side of the mirror. So let's count. So C prime is here. So C double prime will be 1, 2, 3 away from the mirror on this side. So let's count 1, 2, 3. So this is the location. Now we can proceed to draw our new image. So this is our new image triangle after a second reflection in the y-axis. The problem is, however, stating that the image after a second reflection should be referred to as LMN. So we are relabeling as L, M, and N. These are our new image points after a double reflection, first in the x-axis and then in the y-axis. So if we are to describe this transformation, let's call it P double prime, where this is the original object P. So we can write then that P double prime, which is the image after two successive reflections, represents a rotation of 180 degrees about the origin. It can either be clockwise or anti-clockwise. Once it's a 180 degree rotation, it does not matter. Part 3 of this question is asking us to state the 2x2 transformation matrix that will map P onto P prime, and that is -1, 0, 0, -1. This is the 2x2 transformation matrix for a 180 degree rotation about the origin. So for section 4b, we will be solving this inequality. So in the first instance, we will be subtracting 5 from all three sections of this inequality. So we have -7, we're going to subtract 5, that's less than 3x plus 5, and we're going to subtract 5 from this intersection. And then we have less than or equal to 7, and we subtract 5 again. We're subtracting 5 from all three sections of the inequality. So we're actually solving two inequalities at once. So -7 minus 5 is equal to -12 is less than 3x plus 5 minus 5 is 3x, and we have less than or equal to 7 minus 5 is 2. Now we need to divide all sections by 3, so we have -12 over 3 is less than 3x over 3, which is less than or equal to 2 over 3. So this becomes -4 is less than x, and that is less than or equal to 2 over 3. So we can represent this on our number line. So this is telling us that x is ranging between -4 and 2 over 3, but it doesn't quite get down to 4, so we'll put a circle or a hole at 4, and the range will be all the way up to 2 over 3, which would be somewhere around here. So this is our range of values for x, all the way up to 2 over 3, not quite getting down to -4. So we have a hole at this point. Let us move on to the next part of this question 4c. Okay, so in question 4c, we have an equation, and we need to get the equation in the form y is equal to mx plus c, where m, as we know, is the gradient, and c is the y-intercept. So we need to represent this equation in this form. So let us first do that by taking x over 3 to the right side of the equation. So we have y over 7 is equal to 1 minus x over 3. So first step. Then you multiply both sides by 7. So we'll get 7y over 7 is equal to 7 minus 7x over 3, which leaves us with y is equal to 7 minus 7x over 3. From this, we can see that the gradient is -7 over 3, and the intercept is equal to +7. So we can write then that m, or the gradient, is equal to, let's write gradient is equal to -7 over 3, and the intercept is equal to 7. And we should recall that the intercept is where the line crosses the y-axis. So if we have a graph looking like this, this would be our intercept, indicating that the value of x at the intercept is 0. So this is 7. Then the coordinates of this point would be 0, 7. So given that it crosses the y-axis at q, then the coordinates of this point would be 0, 7. So in question 5, we have a statistics question and we are shown a cumulative frequency distribution. So what we're shown is the fuel consumption of 150 vehicles. Let's make that point now. So in the first instance, we're asked to determine the lower class boundary of the class 21 to 30. So let's just identify we have 1, 2, 3, 4, 5 different classes. And in class 2, which is the class 21 to 30, we're asked to determine the lower class boundary. The lower class boundary is found by subtracting a half from the lower class limit. So we'd have 20.5. And just to note that the upper class boundary would be to add a half to the upper class limit, which would be 30.5. So just to make the point that this would represent the lower class boundary and this 30.5 would represent the upper class boundary. So the lower class boundary would be 20.5 for this particular class. So the second part of this question is asking for the class width. So the class width, so let's just write class width. That is defined as the upper class boundary minus the lower class boundary. So that would be upper class boundary. Let's just abbreviate as UCB, where this is upper class boundary. And the lower class boundary we could call as LCB. So it's the upper class boundary minus the lower class boundary. And that works out to be 30.5 minus 20.5. And that is equal to 10. Part 5b is asking for the number of vehicles that were recorded in the class 31 to 40. So we're now asked to determine the number of vehicles recorded in this class. Notice that what we're given here is a cumulative frequency. So in the first class, we would have 24 vehicles recorded. In the second class, we would have the difference between class 2 and class 1, which is 59 minus 24. So let's just make that note. So the amount of vehicles recorded in this class would be 59 minus 24. Let's write that as 59 minus 24. And that works out to be 35 vehicles. So in the class of interest, which is class number 3, we have between 59 and 101, we have 101 minus 59, and that would give a total of 42 vehicles for class 3. So there were 42 vehicles that consumed between 31 and 40 liters of fuel. We could go on to complete the rest of the table. So in class 4, we would have 129 minus 101, which would give 28 vehicles in class 4. And in class 5, we have 150 minus 129. We have 21 vehicles in class 5. So the answer to the question, how many vehicles were recorded in the class 31 to 40, that would be a total of 42 vehicles. So in 5C, we're asked to determine the probability that a randomly chosen vehicle consumed more than 50.5 liters. And that will be equal to the number of vehicles consuming more than 50.5 liters all over the total number of vehicles. So let us determine the number of vehicles that consumed greater than 50.5 liters. If we look at our frequency distribution, we note that in class 5, between 51 and 60 vehicles in that class, the class boundaries would tell us that in class 5, each vehicle consumed more than 50.5 liters. That's a lower class boundary for this class. And in class 5, there are 21 vehicles. Therefore, probability that a vehicle consumed more than 50.5 liters would be the total number of vehicles in class 5, which would be 21, over the total number of vehicles, which would be 150. And we could simplify to give 7 over 50. So in 5D, there is an estimate that the consumption or the median fuel consumption is 43.5. And we are to determine if this estimate is correct. So how do we determine the median fuel consumption? Well, let us just note that if we have vehicles number 1, position number 2, this will be the third vehicle, all the way up to vehicles number 150, then the median consumption is the consumption of any vehicle or vehicles that is at the midpoint. So once we find the consumption of the vehicle at the median position, then we will have found the median. So let us find the consumption of the vehicle at the median position. Let's find the value of the median position. So the median position, it will be the midpoint between 1 and 150. So that works out to be the midpoint, or the median position will be 150 plus 1 over 2. And that is equal to 151 over 2, or 75.5. So once we have a fraction like this, we need to choose average of the fuel consumed by vehicle number 75 and vehicle number 76 would give us the median consumption. So this is what we're after. So if we take a look at our frequency table, we'll note that the first 24 vehicles consumed between 11 and 20 liters. The next 35 vehicles consumed between 21 and 30. That goes up to vehicle number 59. And then the next 42 vehicles consumed between 31 and 40 liters, and that will take us between 59 and 101. Therefore, both the 75th and the 76th vehicles would be in this class, and the consumption of fuel in this class would be estimated at 30.5 to 40.5 liters, and therefore, let's write, so the median consumption is between 30.5 and 40.5 liters. Therefore, 43.5 is too high an estimate and is therefore incorrect. So in 5E, we're asked to draw a histogram based on this distribution shown in the table. So the histogram is basically a bar chart with no spaces. So because there are no spaces, we will need to use the class boundaries and not the class limits. Notice that we do have spaces in the classes. For example, in class 1, the consumption is between 11 and 20. In class 2, it's between 21 and 30. So there is no information between 20 and 21. So we will need to close that gap using the class boundaries. So if we use a class boundary for this class, we'll write 10.5, and that would go up to 20.5, and then from 20.5, notice we have no close the gap, it would go up to 30.5, and we continue like this. So in all 5 classes, we have the class boundaries shown, and we'll now need to plot this on our histogram. And how we're going to do this is we're going to start with the lower class boundary at the origin, so this would be 10.5, and note that we are going up in steps of 10, so this would be 20.5, 30.5, and so on. So now that we have our class boundaries or the lower boundary on our histogram, we can plot the height, which is the frequency, using the information given in the frequency column. So 10.5, as you can note, would correspond to 24. So let's look for 24 here. So 10.5, 24 will be here. 20.5 would correspond to 35. 30.5 corresponds to 42. 40.5 corresponds to a frequency of 28. 50.5 would correspond to a frequency of 21. And now that we have those, let's draw vertical lines. And now all we need to do is to draw horizontal lines. And this would complete our histogram. And if you like, we could insert the frequencies to indicate the height of each bar. So the first class, the height of this bar is 24, and it goes up to 35, 42, 28. Finally, the last class in 50.5 and 6.5 is 21. Let's move on to the next question. So in question 6a, we have a map and a scale given for this map. So what the scale is telling us is that 1 unit on the map represents 25,000 units in actual distance. So if we start with centimeters, we could then infer that 1 centimeter on our map would represent a total of 25,000 centimeters of actual distance. So if we convert centimeters to meters, then we have 1 centimeter then would represent, divide this by 100, 250 meters, or we could go a step further to say that 1 centimeter then would be representing 250 divided by 1,000 to be 0.25 kilometers. So 1 centimeter on our map would represent an actual distance of 0.25 kilometers. The question goes on to ask, what would a distance of 0.5 centimeters on our map represent in actual distance? So if 1 centimeter represents 0.25 kilometers, then 0.5 centimeters would be half of this, or 0.25 divided by 2, or 0.125 kilometers. In part 2 of the question, we're asked, what is the area in kilometers squared that is represented by 2.25 centimeters squared? This is on the map. So if we have 2.25 centimeters squared on a map, what does that represent in actual area in kilometers squared? How I like to start is by drawing a 1 centimeter square block. So this is 1 centimeter by 1 centimeter. And if you notice, the area of this block would be 1 times 1 is 1 centimeter squared. And since we know that 1 centimeter on the map represents 0.25 kilometers, then this 1 centimeter square block would also represent a square block of 0.25 by 0.25 kilometers. And therefore, the area of this 0.25 square block would be 0.25 times 0.25, so that would be 0.0625 kilometers squared. So 1 centimeter square on the map would represent a 0.0625 kilometers squared in actual area. So if 1 centimeter squared represents 0.0625 kilometers squared, then 2.25 centimeters squared would represent 2.25 times 0.0625, and that would give 0.1406 kilometers squared. Let's move on to the next question. So here we have two jars, two cylindrical vessels. We denote them as X and Y. And first, vessel X, and it is cylindrical, is filled with water to a height of 4 centimeters, and its diameter is given as 3d. This compares to vessel labeled Y, whose diameter is d. So this jar Y is empty. So initially, jar Y is empty, and we note that jar X has 4 centimeters of water contained in it. So we could find the volume of water in that jar. So we could find the volume of water in jar X. We could call this as Vx. That's equal to pi r squared h, where pi, the radius squared, times the height, which is 4 centimeters. Now this can also be written as volume is equal to pi times the diameter squared over 4. So we could write it as pi times d squared over 4 times the height, which is 4, where d, the diameter, is given as 3d. So let's write where d is equal to 3d. So we could write then that Vx is equal to pi times 3d all squared over 4 times 4. These two would cancel, and we're left with Vx is equal to 9 pi d squared. So that's an equation for the volume of water in jar X. So this represents volume of water. So the question goes on to ask, if we were to pour all of the contents of jar X into jar Y, what would be the height of water in jar Y? So we note the volume of water in jar X. So if we pour the entire contents into jar Y, then volume of water in Y would be equal to the volume of water that we just poured from X. So that would also be equal to 9 pi d squared, and that represents the volume of water in jar Y. So since we know that the volume of water in jar Y can be written as Vy is equal to pi, in this case it's small d squared, 4 times the height, and let's call this height h, or we need to determine the height h, we can then determine that 9 pi d squared is equal to pi d squared over 4 times h, and we can do some manipulation here. So h works out to be 4 times 9 pi e squared all over pi e squared. These two will cancel, and you'd have 36 centimeters of water in jar Y. Let's move on to question number 7. So in question 7a, we're given a sequence in terms of n, and we're given the formula showing that Tn is equal to 3n squared minus 2. Tn therefore means that if n is equal to 1, then T1 is equal to 3 times 1 all squared minus 2. That is equal to 3 minus 2 is equal to 1. Similarly, if n is equal to 3, then T3 will be equal to 3 times 3 all squared minus 2. And that's 3 times 9 is 27 minus 2, so it's 25. And this is how you would interpret this particular sequence. So if in one instance we have Tn is equal to 145, then we could determine the value of n by applying this to this formula. So we could write 3n squared minus 2 is equal to 145 based on this formula, and therefore we can determine the value of n by transposition. So 3n squared will be equal to 145 plus 2, therefore n squared is equal to 147 over 3, and that is equal to 49, and therefore n is equal to plus or minus square root of 49, which is equal to plus or minus 7. Now in part B of this question, we're given another sequence, and we are shown the values of n, and in this case it is un that is the function. So if n takes on a value of 1, un is equal to 1. If n takes on a value of 2, un remains at 1, but it starts increasing when n takes on values greater than 2, 3, 4, all the way up to 10 as shown in this table. So if we're given that un is equal to un minus 1 plus un minus 2, that is simply saying that u10 would be equal to u9 plus u8. Simply means I subtract 1 to get 1, I subtract 1 to get 1 less than 10, which is 9, then I subtract 2 to get 2 less than 10, which is 8. So this is all that is saying. So it's actually adding the two lower numbers as shown here. So we can deduce quickly that u5 would be simply u4 plus u3. So we could add these two. So u5 is 4 plus 3. And if you notice, we can actually extract that from the table. Because here we have u5 equal to 5. And it's predicting that it's also equal to u4 plus u3, which is equal to 3 plus 2, which is equal to 5, which is predicted from our table here. We could continue like this. So we could write that u9 is equal to u8 plus u7. So here's u9. We could fill in this position on the table, because u9 is just simply the sum of these two, 21 plus 13, and that would be 34. And of course then u10 will be equal to u9 plus u8. So we're now going to add these two at u10. So u10 is 34 plus 21, that's equal to 55. So just to make the point, that's equal to 34 plus 21, which is equal to 55. The one we had earlier was 21 plus 13, and that was equal to 34. So by extension, we're asked which term in the sequence is actually summing u18 plus u19. That is clearly u20, because these are the two lower numbers. u18 plus u19 will be equal to u20. So that is a simple conclusion based on this sequence. Okay, so in this part of the sequence question, we're asked to show that u20 minus u19 is equal to u19 minus u17. So we're asked to show this. So let us examine U20 and write U20 as U20 is equal to U19 plus U18, and this is coming straight from the sequence. Therefore, we can write that U18 is equal to U20 minus U19. We could call this equation 1, and we can also write that U19 is equal to U18 plus U17, also coming straight from the sequence. Therefore, U18, forming an equation for U18 again, we have U19 minus U17. And if you notice, let's call this one equation 2. So equating 1 and 2 gives U20 minus U19 is equal to U19 minus U17, which is what we set out to show. So in question 8a, we're given two functions, a function f of x and another function g of x. The first question is, what value of x cannot be in the domain of f of x? So let us use a diagram to try to explain what that really means. So if you imagine that, for example, we had a function f, its output was f of x in response to an input x. So x goes into the function and out comes the value f of x. So if x is equal to 1, the output would be f of 1. So in this case, the question is there a value that x cannot assume? If there is such a value, then we say that that value of x cannot be in the domain of this function, which means x may take on many different values, 1, 2, comma, -1, -2, etc. But there may be a particular value that if x took on that value, after you apply to the function, the output would be meaningless or undefined. So if x is such that the function is undefined, and undefined here means we don't know what it is, it has a meaningless value, then we should avoid that value of x. And in so doing, we say that we cannot allow that value of x to be in the domain of f, which means we will not apply that value of x to the input. So we will not allow it to be part of the set of values of x that we apply to this function, and therefore we say it cannot be in the domain of the function. Remember, the domain of the function is simply the set of values of x that we can apply to the function. So is there such a value that we should not apply to this function? F of x is equal to 9 over 2x plus 1. So let us investigate if there is such a value. Now, recall that I said if x makes the function undefined, then we cannot use that value of x. And we note that the function is undefined when the denominator is equal to 0. So the question is really asking us to find the value of x which will make the denominator of this function equal to 0. That is, if 2x plus 1 is equal to 0, then the function will be undefined. So by simple algebraic manipulation, we get 2x is equal to -1, therefore x is equal to -1 over 2. We can state then that if x assumes the value of -1/2, the denominator will go to 0 and the function will be undefined. This means that x is equal to -1/2 cannot be in the domain of the function, which means we will avoid applying x is equal to -1/2 to this function because the output will be meaningless or undefined. So part 2 is asking for an evaluation of the composite function f g of x. Now whenever you see this, it means that we are going to place g into f, which means the function g of x will replace the value of x in the function f of x. So let's write f of x, and we know that g of x is equal to x minus 3. So wherever we see x in f of x, we're going to replace g of x. So we could rewrite as f of g of x would be equal to 9 all over 2 of g of x plus 1. And then we simply replace g of x with the value that we have in terms of x. So that is equal to 9 all over 2 times x minus 3 plus 1. So we could continue. That's equal to 9 over 2 by x is 2x. Plus 9 over 2x minus 6 plus 1, which is equal to 9 over 2x minus 5. So that is a simplified expression for f g of x. In part 3 of this question, we are asked to provide an expression for f to the minus 1 of x, which is inverse of f. So we let y be equal to the function f of x, and therefore we can say then that replacing the function f with y, we could write then that y then becomes equal to 9 over 2x plus 1. All we're doing is substituting y for f of x in the first instance. It's just a convenient way of changing this variable so we could move a little faster. So the first thing we would want to do here is we want to swap around x and y, or exchange x with y and y with x. So we let this becomes equal to x over 9 over 2 y. We change this x to y plus 1. So we interchange x and y. Now we transpose for y. So we multiply both sides by the denominator, and we have x into 2y plus 1 is equal to 9. So we expand, and we have 2xy plus x is equal to 9. We take x to the right side of the equation, and we have 2xy is equal to 9 minus x, giving y as being equal to 9 minus x over 2x. This is our result. So we can rewrite as f to minus 1 of x as being equal to 9 minus x over 2x. In part B of this question, we have a diagram showing two rectangles, an inner rectangle and an outer rectangle. The dimensions are given, a part of which is given in terms of x, and we are given that the area of this rectangle is equal to 44 cm squared. So we could write that area is equal to 44 cm squared, and we know that that is equal to the length by the width. But the length is given as 4 plus 3x, so the length is given as this one here. So we could write then that length is equal to 4 plus 3x, and width is equal to 2 plus 3x. And these are all in units of centimeter. So we could then say that length multiplied by width is equal to 44 cm squared. So we could write that 4 plus 3x multiplied by 2 plus 3x. That would be the area, which we know to be 44 cm squared. We could expand these terms here. So let's distribute the results. So first we multiply 4 by 2, then 4 by 3x, and we will get 4 times 2 is 8 plus 12x. And we distribute these two, and we have 3x times 2 is equal to 6x plus 3x times 3x is 9x squared, which gives 9x squared plus 18x plus 8 is equal to 44. We take the 44 to the left side of the equation, and we get 9x squared plus 18x plus 18 minus 44, and that's equal to 0, giving 9x squared plus 18x minus 36 is equal to 0. And this can be simplified further because we can divide throughout by 9, and we get x squared plus 2x minus 4 is equal to 0. So now we need to find a value for x by solving this equation. And since this is a quadratic equation, then we expect to have two values if we equate that to 0. So let's just rewrite across here. So it's x squared plus 2x minus 4 is equal to 0. So we're going to use the quadratic formula to solve this equation. So in this case, we have a is equal to 1, b is equal to 2, and c is equal to negative 4. So by applying the quadratic formula, you know this to be x is equal to minus b plus or minus square root b squared minus 4ac all over 2a. So we simply plug these values into this equation, and in the first instance we get negative 2 plus or minus 4 minus all of this 4ac. A times c is negative 4, so it's going to be 4 times -4 all over 2 times a, which is 2. So this works out to be -2 plus or minus square root of 20 all over 2. And this would, of course, give us two values, where the first value is -1 plus root 20 over 2. And the second value would be -1 minus root 20 over 2. In the first instance, we know this is equal to 1.236. And this value is negative, which we could ignore this value because we don't expect x to have a negative value. So we could ignore the negative result and give x as being equal to 1.236 to 3 decimal places. Next, we need to find the perimeter of the unshaded area. So let's just identify that area here. So this is this area I've denoted here. So we need to find the perimeter of that region. So let's proceed to do that. We know perimeter is equal to 2 times your length plus width, where the length is equal to 4 plus 3x. That's right. We know that to be 4 plus 3 times 1.236. And that works out to be 7.708. We also have the width as 2 plus 3 times x, which is equal to 2 plus 3 times 1.236. And that works out to be 5.708. So our perimeter is equal to 2 multiplied by the length plus the width, which is 2 into 7.78 plus 5.708. That works out to be 26.832. Okay, so question 9a is a problem in circle geometry. So we're asked to find three angles given this object. So in the first instance, we're asked to find the angle DBA. Let's identify that angle. So the angle DBA. So this would be DBA. So this angle here, we'll call this angle X. So in order to find angle X, let us utilize this diagram which shows a portion of this original figure. So if you notice, I've highlighted the area of interest, and that is to demonstrate that line AOC is the diameter of that circle. Therefore, any angle that subtends at the circumference from the diameter is equal to 90 degrees. And therefore, if we are asked to find this angle, which I have called X, then it simply means that X plus 46 is equal to 90 degrees. Let's write X plus 46 is equal to 90 degrees. And that's because angles in a semicircle are equal to 90 degrees. Therefore, X is equal to 90 minus 46, and it's equal to 44 degrees. So let's stick that in. So also let's stick that here as well. Our next task is to find angle DAC. Let's identify DAC. So that's DAC. So let's just identify this as angle DAC. And let us call that angle Y. Now, if you note immediately by using this diagram here on the right, we're using just that portion of the figure that we need to demonstrate the theorems that we're going to be using. And if you will notice that DC is a chord, and both angle A and angle B are subtended from that chord in the same segment, and therefore Y is equal to 46 degrees because angles in the same segment are equal. So let's stick Y in as well. Finally, we're asked to determine angle BCE. Let us identify BCE. So that's BCE. So that's this angle here. Let's call this angle Z. So in order to determine angle Z, let us use this figure on the right as an illustration. And here we are showing that ABCD is a cyclic quadrilateral. So let's make that note. ABCD is a cyclic quadrilateral, and in a cyclic quadrilateral, the external angle is equal to the interior opposite angle. So if we have an angle x0, in this case we are calling it Z, then this angle will also be equal to Z because these two are equal. So let's write Z is equal to the interior opposite angle here. And we note that the interior opposite angle is the angle at A, which is equal to 46 plus 28. So let's just write Z is equal to 46 plus 28, which is simply adding these two angles, which is equal to 74 degrees. So we can write then that the Z is equal to 74 degrees because in a cyclic quadrilateral, the external angle is equal to the interior opposite angle. So this is just to demonstrate that the external angle as shown here, which I refer to as x0, is equal to the interior opposite angle, which is indicated here at A. So move on to the next question. So in question 9b, we're asked to find a few angles and a few sides. The first instance, we're asked to find the side PS, which I have called X. So we need to find X, we need to find the side Y, we need to find the angle Z, and we need to find the side Q. So let's do them in order. So in the first instance, let's find angle X. And if you notice, angle X is a part of a right angle triangle. This is given as 90 degrees. So we have many techniques available to find the angle or a side in a right angle triangle. So if you note that PQ and SR are also known to be parallel to each other. So if that is the case, then SQ is merely a transversal. So if you notice, we could use a theorem of alternate angles to recognize that PQS is the same as this angle because this angle is the alternate angle of this angle. So we could write the angle here. It's denoted in a different color. So this angle would be equal to 30 degrees because this is the alternate angle and that's equal to 30 degrees. So in the first instance, we would state that PQS, angle PQS is equal to 30 degrees because alternate angles are equal. This is sometimes referred to as your Z angle. So just to make that point here. So we note this to be 30 degrees. So we can apply the sine ratio in this case because the sine of this angle 30 degrees is equal to x over the hypotenuse, which is 8 centimeters. So we could write that the sine of 30 degrees is equal to x over 8, giving x is equal to 8 sine 30 degrees, which is equal to 8 times a half or 4 centimeters. So let's just stick that in. So x is equal to 4 centimeters. Next, we need to determine the side or the length of the side y. So this is nothing more than the adjacent to this angle. So we could use the cosine ratio in this case, and we could write the cosine of 30 degrees is equal to y over the hypotenuse, which is 8, giving y as 8 cosine of 30 degrees. That is equal to 6.928 centimeters. So we could write y in here as well. So now we need to find the angle Z. So note that Z is nothing but one angle of the triangle SQR. So considering triangle SQR, we have Z is equal to 180 degrees minus the sum of the other two angles, which are 30 degrees plus 82 degrees, giving Z as being equal to 68 degrees because angles in a triangle add to 180 degrees. Let's add the value Z to our diagram. Finally, we need to find the area of this trapezium. So let's just note that we need to find the area of the trapezium PQRS. So we need to find the area of this trapezium. So we know that the area of a trapezium is equal to half the length of the parallel side. So it's equal to half of y plus q multiplied by the vertical distance between, and that would be x. We have already found x and y. So let's go ahead to find q. So we will need q in order to find the area of this trapezium. So let's consider triangle SQR, and we will apply the sine rule because we have two angles and one side. So we could apply the sine rule to find the other side. So let's just form an equation using the sine rule. So we have q over the sine of q is equal to r over the sine of r, where r in this case is equal to 8 centimeters. That's identified here. And we have angle r is the same as the angle that we have denoted here as z. So we could write that q is the unknown, over the sine of q, which is the sine of 82 degrees, and that's equal to r, which is 8 centimeters, over the sine of r, where r is equal to 68 degrees. So we have one equation, one unknown, so we could solve by noting that q is equal to 8 multiplied by the sine of 82 degrees over the sine of 68 degrees, giving q to be equal to 8.544 centimeters. Therefore, we could write that the area of the trapezium, let's write the area of the trapezium is equal to half length of the parallel sides, which is y plus q, y is equal to 6.928 plus q, which is 8.544, multiplied by the vertical distance between, which is 4, and that gives 30.94 centimeters squared. Let's move on to question number 10. For question number 10, let us first expand these two matrices. And therefore, it's negative 1 times k, so it's negative 1 times k plus 15. And the second expansion is 4 times k plus 5h. These are the two expressions that we are getting from the expansion. So the second part of this question, we're given that this matrix product is equal to 0, which means negative 1, 3, 4 and h multiplied by k and 5 is equal to 0, 0. So the solution to this would be simply to equate equation 1 to 0 and equation 2 to 0, because we have already expanded this matrix product. So we could write then that negative k plus 15 is equal to 0, and that's from 1. And from the 2, we could write that 4k plus 5h is equal to 0. So this is called one 3, this is called equation 4. So from 3, we get that k must be equal to 15. And from 4, we simply substitute k into equation 4 to give 4k plus 5h equal to 0. Substitute value of 15 for k, so we have 4 times 15 plus 5h equal to 0. So 5h is equal to negative 60, therefore h is equal to negative 12. In 10b, we will need to solve this pair of simultaneous equations using the matrix method. So let us establish the matrix equation. So for the coefficients, we have 2, 3, negative 5, and 1 multiplied by x and y is going to give us 5, 13. So that is our matrix equation. To get x and y, we simply multiply both sides by the inverse of this matrix. So let's call this matrix A. So let's find the inverse of matrix A. First, let's establish the equation. So x, y is equal to the inverse of A times 5, 15. So let us find the inverse of A. So A to the minus 1 is equal to the adjoint of A. This is over the determinant of A, where the adjoint of the matrix A, that's right, adjoint of A. Let's just make some space across here. Where adjoint of A is abbreviated as ADJ, adjoint of A. And to find the adjoint of a matrix, you note that you have two diagonal elements, two leading diagonal elements, 2 and 1. So we interchange these two, or swap them around. So we interchange 2 and 1. So 1 will be here, and the other diagonal element will be swapped around and it's down here. And then we change the sign, or we reverse the sign of the non-leading diagonal elements. So 3 becomes negative 3, and negative 5 becomes 5. That's our adjoint matrix. Our determinant, which we'll abbreviate as D. Determinant of A is simply the product of the leading diagonal elements minus the non-leading diagonal elements. So we'll have the product of the leading diagonal elements is 2 times 1. We subtract the product of the non-leading, which is 3 times negative 5, giving 2 plus 15, that's equal to 17. So our determinant is equal to 17. So our inverse matrix is equal to 1, negative 3, 5, 2, all over 17, which we can rewrite as 1 over 17 into 1 minus 3, 5, and 2. So that's our inverse matrix. So we could substitute this inverse matrix into our equation. So this means that x and y are equal to the inverse matrix as 1 over 17, 1, negative 3, 5, and 2, multiplied by 5, 15, giving x and y is equal to 1 over 17, and after multiplication of these two matrices, we get negative 34 and 51, giving a final result of x then being equal to negative 2 and y equal to 3. Okay, so let us move on to question 10b, vectors question. So notice we're given a diagram and we're noting that this is referred to as the origin, which means we have points B, D, A, and E relative to the origin O at 0, 0. So our challenge is to find the vectors AB, OD, and BE, and we're given other information about this particular triangle. We're given that AD, which is from A to D, is equal to 1/3 of AB. All this means is that this is 1/3 of the total distance. Similarly, OE is given as 1/3 of OA, and it has the same meaning. The distance between 0 to E is 1/3 of the distance between 0 to A. That is all that means. So we need to use a vector method to determine AB. So we need to find the vector AB. If you notice, AB is going in this direction. So first, let us write these points as position vectors. So point B with coordinates 3, 6 has the position vector O to B, and that is 3, 6. Similarly, point A with coordinates 9, 0 has the position vector OA, 9, 0. So let us now determine the vector AB. To find the vector AB, we imagine that we are at A and we need to get to B. So we're going to find a path to get from A to B. So we could travel in this direction from A to O. Then we could go from O to B in this direction. So let's write vectorially that AB is the equivalent of going from the A to O plus the vector going from O to B. Now, if you notice, we have values for these two vectors because AO is simply the inverse of OA. See that again? The vector going from A to O is simply the inverse of the vector going from O to A, and we have a value for that. So we could write that A to O is simply the negative of the vector OA, and OB we note to be 3, 6. So we can write then that AB vector 3 minus 9 is negative 6, and 6 minus 0 is 6. So the vector AB is negative 6 and 6. So next we need to find the vector OD. So let us first identify OD, and OD is a vector going from O to D, and we have identified it here. This is a vector OD. So let's just write vector OD going in this direction. So to find the vector OD, let's write OD the vector. We are going to take the path where we go from O to A in this direction, and then from A to D in this direction. So we are going from O to A, so we're going to go along OA, and then we're going to go from A to D in this direction. So the vector O to D then is equal to O to A plus A to D. So do we have values for these vectors? Well, we know the vector OA because we have been given that as 9, 0. So that's 9, 0 plus the vector A to D. So note that A to D is 1/3 the vector A to B. So let's just write 1/3 the vector A to B. But we already know the vector A to B because we found it here. Therefore, we can write that this is equal to 9, 0 plus 1/3 of A to B, where A to B is negative 6 and 6. So that gives 9, 0 plus negative 2 and 2. So we add these together, we have 9 minus 2 is equal to 7. 0 plus 2 is equal to 2. So the vector OD is equal to 7, 2. Let's write this here. Finally, we need to find the vector BE. To find the vector BE, first let us identify the vector BE. So the vector BE is the vector going from B to E. So it's going in this direction. Let's label it. It's vector BE. And if you imagine that you are at B and you need to get to E, you could first take the path from B to O and then from O to E. So let's identify our journey. So this is the path we will be taking. We'll first go from B to O in this direction, and then from O to E in this direction. So we could write vectorially then that the vector BE is the vector going from B to O plus the vector going from O to E. Do we have values for these vectors? Well, the vector B to O is simply the inverse of the vector OB, and we have that as 3, 6. So the vector BO is simply negative of the vector OB, which is negative 3, 6. And the vector OE, well, if you notice, the vector OE is 1/3 the vector OA. So let's write vector OE is 1/3 of the vector OA, where we know OA to be 9, 0, so we could replace that with negative 3, 6 plus 1/3 of 9, 0, giving negative 3, 6 plus 3, 0. And if you add these together, we'll have 3 minus 3 is equal to 0, and 0 minus 6 is equal to negative 6. So the vector BE is equal to 0, negative 6. And this looks like we are at the end of the May 2019 paper, so I'll see you soon.